السلام عليكم ورحمة الله وبركاته. Good evening. My name is Akram. SPE-KSA, I would like to thank you for taking the time to join us in tonight's interesting webinar as part of SPE-KSA. To our webinar, please allow me to run a quick poll to know our audience better before we get into it. And if you don't mind, please, I will launch the second and the final question, I promise. Thank you very much for participating in our poll, and we welcome those who are not SPE-KSA members yet to follow us on the Twitter account to learn more about our events, and activities. I'd like to remind everyone that at the end of this session, there will be a Q&A session that you can submit your questions through the Q&A button at the bottom of your screen, and we will be asking the speaker at the end of the session. The fourth industrial revolution, IR 4.0, is creating a worldwide digital transformation programs that will lead to considerable improvements in operational efficiency and sharp increases in business margins. Blockchain, or sometimes referred to as distributed ledger technology, DLT, is a well-recognized innovation that is mostly used in financial sectors. They are data structures that secure digital transactions that cannot be altered. Our webinar tonight will give you an overview of the technology behind blockchains and how they redefine the digital trust in a time increasing of cybersecurity concerns. Our speaker, Mr. Jon Curtis, is the founder of Petrolink and the founder and chairman of B2B Matrix, a company with a primary focus on the implementation of the blockchain technologies in the energy sector. He is a member of the numerous professional organizations and the current liaison officer of the SPE's Drilling Uncertainty Prediction Technical Section, DUPTS. Mr. Curtis authored multiple SPE papers, including those concerning the data architecture of real-time drilling and completion information and the integration of real-time. So without any further ado, I'll leave the floor to Mr. Curtis to start the webinar.
Good evening, everybody, and good afternoon to members of the Society of Petroleum Engineers, Kingdom of Saudi Arabia Branch Chapter, and Salam Alaikum to you all. My name is Jon Curtis, and I'm your speaker for this evening. I'm hoping that this presentation will be both informative and thought-provoking at the same time. The advent of blockchain technology as a force for disruptive change has been compared to the beginning of the internet itself. It is termed by some as the network of networks, and it is my hope that by the end of this webinar, some of the reasons why may be a little clearer. The importance of this disruptive technology has already been recognized by Saudi Aramco in this public document on the fourth industrial revolution, which was sent to all current contract holders earlier this year. This later page of the same document shows that blockchain is one of the technology tracks. As this is a very recent evolution within the fourth industrial revolution, it is likely that there will be some innovation partners involved in the future implementation of blockchain. Here in this latest slide, blockchain is once again mentioned. In this case, it has been included as part of cloud provider solutions. So let's have a closer look at this technology. Following a brief general description, I will move on to show some examples of how it can be used to support drilling operations. In 1991, a group of engineers started to look at digital timestamps of documents as a way to ensure that they could not be altered and then subsequently backdated. But there was then very little further development of this timestamping of documents or data until the creation of the digital cryptocurrency Bitcoin in 2009. In 1997, a cryptographer called Nick Szabo was looking at ways to use a distributed ledger to store contracts electronically. But again, little had been done at that time until the creation and the release of the white paper. The real potential of these inventions was not realized until shortly after the financial crash of 2008, when a still as yet unidentified person or persons called Satoshi Nakamoto released a white paper in which a new peer-to-peer financial system was discussed. It outlined the creation of a digital cryptocurrency that would enable financial transactions to be undertaken without the need to go through financial institutions like a bank. Most importantly, the paper outlined how the so-called double spend problem could be solved. This cryptocurrency was called Bitcoin. Because of the fact that these digital currencies were not initially subject to regulation, the technology attracted criminal elements who used it as a way to pay for illegal transactions and also to launder money into the financial systems. It became clear that cryptocurrencies needed to be subject to regulation. As of February 2020, Bitcoin was legal in the United States, Japan, the United Kingdom, Canada, and most other developed countries. The underlying technology of Bitcoin, as outlined in the Satoshi Nakamoto white paper, is called blockchain. Indeed, the Saudi Arabian Monetary Authority, SAMA, has itself already deployed blockchain technology for money transfers between local Saudi banks, as seen here in this internet link. One of the problems that we face in the oil and gas industry is that of multiple copies of the same information, and this can lead to confusion and even serious mistakes. Blockchain enables documents to be time-stamped in a record that is immutable. In other words, it can never be changed. This effectively enables a data audit to be implemented for almost any type of data that is recorded in a typical well construction process. The primary consideration, after that of safety, of course, in the well construction process is one of prediction and avoidance of well incidents that lead to non-productive time and the reduction of invisible lost time through drilling optimization. Blockchain offers considerable scope to provide solutions to enable both of these aims. Individuals and group of individuals, such as a real-time operations center, can exchange information in a consensus blockchain as defined by a so-called smart contract. A smart contract, such as an alert mechanism for a BOP warning, can be triggered by addressing a data transaction from that equipment into a consensus blockchain. This alert then executes independently and automatically on every node in the network, so that every node, person or persons in a real-time operations center are notified simultaneously. This diagram may seem confusing at first sight, so I would like now to step back and take a deeper look in how blockchain, and more specifically the smart contracts that can run on the blockchain, actually work. I've put together a series of slides here which will help in understanding the basis of blockchain technology. Blockchain technology has been called the next evolution of the internet, or the ultimate network of networks. So what is it? Each block consists of some data, a hash of the block and the hash of the previous block. For example, here, the block could contain some data that could be a drilling alert, for example, or a metadata value such as drilling mud weight, both of which are important in the well construction process. And the hash of the block is shown as this encrypted long string of characters. This hashing requires processing of data through a mathematical function, which results in the output of a fixed length. Using this fixed length output increases security, since anybody trying to decrypt it won't be able to tell how long or short the input is simply by looking at the length of the output. Cryptography here is security through mathematics and software code. Here is the hash. The hash can be likened to a fingerprint. It identifies the block and all of its context, and it's always unique, just like a fingerprint. Each block consists of the data, as I mentioned, a hash of the block and the hash of the previous block. So if the fingerprint changes, it is no longer the same block. Changing something inside the block causes this hash to be changed. So these hashes are very useful when you want to detect these changes. So here's what is a blockchain. The chain is a series of the blocks which contains the previous block and a hash of the previous block. How are these blocks linked in a blockchain? Here is an example showing them with the hash values underneath. The chain of 3 blocks, each of which has a hash and a hash of the previous block. Block 3 points to block 2, and block 2 points to block 1. The first block, which is represented here by the value 000s, is a special block called the Genesis block. Now, what happens if this block is compromised? The example shows that block 2 has been tampered with, possibly by a hacker, who has caused the hash of that block to change. Subsequent blocks are now invalid. However, with hashing alone, very powerful computers would still be able to break the algorithms. So the original blockchains for cryptocurrency also had something called the proof of work. This is a mechanism that actually deliberately slowed down the creation of new blocks. And it worked by requesting each node to solve a cryptographic puzzle. In the case of Bitcoin, it took about 10 minutes to create a new block and add it to the chain. Solving this puzzle became the full-time employment of so-called Bitcoin miners. Mining Bitcoins takes a lot of computer power and therefore electricity because of this proof of work algorithm. However, the proof of work and a later variant of that called the proof of stake makes it very difficult to tamper with a block because you would then need to recalculate the proof of work for all of the following blocks. So the summary of the architecture: when someone joins the network and becomes what's called a node, he or she would get a full copy of the blockchain, and the node can use to verify that everything is still in order. When a new block is created, it is sent to every node on the network. Each node can then verify the block to make sure it has not been tampered with. All of these nodes in the network create a consensus. They agree which blocks are valid and which are not. Blocks that are tampered with will be rejected by other nodes on the network. So to successfully tamper with the blocks on the chain, you would need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of more than 50% of the peer-to-peer network. Only then would your tampered block be accepted by everyone else. In a distributed or decentralized network, each participant on the blockchain network holds an identical copy of the ledger. When a new record or block is created, all of the other nodes are also updated. The participants, or actors as they're sometimes called, are aware of the new data available. Any attempt to tamper with the blocks on the network is also brought to the attention of the other actors. Blockchains are constantly evolving, and one of the most important evolutions is the creation of smart contracts. As mentioned earlier, a smart contract was first used by Nick Szabo in 1997, some time before Bitcoin was invented. But now these smart contracts are the real massive potential of consensus blockchain implementations in the energy industry. Because of these contracts, which are encrypted lines of computer code, stored in the blockchain, they inherit some very valuable properties. They are immutable, unchangeable, and distributed amongst all of the nodes, which brings complete trust to the participants. I showed in this diagram generally the different types of blockchains. The cryptocurrency blockchains are typically open so that many actors can participate. However, for the use of blockchains in the energy industry, we are far more interested in private or so-called consortium blockchains, shown here on the right. Here, the actors have to be pre-approved and are known entities. So finally, to summarize, the key elements of the blockchain going forward, looking at the examples I'll bring, are the distributed ledger technology, the fact that these records are immutable, and the availability and the real power of the smart contracts. I've listed here some of the industries which are already being disrupted by blockchain, and I've put here specifically those that might be relevant to the energy industry. The whole list is very, very large. In fact, it's touching all aspects of industry, commerce, engagement of companies, business to business, right across the whole sphere of activity. Identity management or governance. Here the potential is for voting, but it can also be used for equipment and individual identification on the engineering blockchain, and I'm going to focus on that in the coming slides. Distributed ledgers offer enhanced methods for proving who you are, along with the possibility to digitize documents with the provenance, where they come from. In supply chain management, for example, rig vendor supply relationships and invoicing mechanisms, here there is the potential to reduce or even eliminate the current paper-based systems that are still in place. In the case of energy management, it has been a highly centralized industry for a long time, but there are already many initiatives in electricity energy management in the renewable sector. Energy users and producers cannot buy electricity directly from each other and must go in through public grids at the moment. Blockchain has the potential to allow direct peer-to-peer relationships and will enable the creation of smart grids for smart buildings in smart cities. For intellectual property, there is huge promise for the protection of copyrights, for the guarantee for the first record of ideas, and a framework for management. I've shown here an example of the probable transformation of the market structure for electricity generation and distribution On the right, we see the new streamlined structure with the implementation of blockchain. These changes are already starting to be applied in the energy sector. This is a very detailed analysis of the current blockchain projects in the oil and gas sector in a paper recently published. I've added the link at the bottom, the name at the bottom, for those who are interested to look further into this subject. This is a very detailed document of 100 pages. So let's look at our industry halfway through. Consensus blockchains in upstream. So let's imagine that we have a group of people who wish to share information and communicate together. A group of actors who would be pre-authorized and then participate in a private, decentralized, autonomous organization, which will define the rules by which they collaborate. In such a consensus blockchain, only these known and trusted persons are able to participate. And each person or unit of people, for example, a real-time operations center, becomes then a node on that blockchain. So here's a group of 4 participants in the blockchain: the drilling contractor, the company man, the drilling engineer, and a real-time operations center that's supporting those people on the remote rig. And each of them have an identical copy of the blockchain available. The drilling contractor creates a new record. It could be a drilling report, a casing report. It could be an alert. It could be a notification that he wishes to reach the other people in the blockchain, and he adds it to the blockchain. The smart contract then synchronizes the blockchains of the 4 actors and ensures that all of them are aware and available that the information has been updated automatically wherever they happen to be. And so finally, we come back to the diagram I showed before. And now perhaps it makes a little bit more sense. On the left, we see engineering data, and the example here is shown as a BOP. It could be the pressure on a BOP line. It could be the fact that a BOP is open or closed. And the opening or closing or some form of change of state or alert triggers an alert notification which is entered into the blockchain. In the top left, we see an actor who might be notified that such a change has taken place. And according to the rules of the smart contract, he might then acknowledge the fact that he has seen, for example, an unsafe situation like a BOP line being left opened. And then by acknowledging that, the acknowledgement itself is then sent to every actor on the network. So that could be the drilling superintendent, it could be the real-time operations center, it could be a host of other people. So you take this one example, which is a simple value of engineering data, but it could be all of the equipment on the rig. It could be the whole well construction process, which is recorded in an immutable blockchain, which can be referenced and accessed not only by the actors, but also by applications which have an API connection through to that particular blockchain. So here's an example of a drilling event. In this particular case, and I've chosen a stuck pipe event. So the pipe is stuck, and this has triggered in a data acquisition system, an edge device, which is receiving the data from, for example, a drilling acquisition system. It's triggered an alert record, which contains not only the state of the alert, which could be a simple 0 or 1. Yes, there is alert. Yes, there is a high risk of stuck pipe, plus the related engineering values. It's committed to the blockchain. And then on the right, I show the actors who are notified of this particular change of state. And in fact, you can see some green. The drilling contractor has already notified, and the real-time operations center and other actors, for example, the company man, the drilling supervisor, are aware of the fact that the drilling contractor knows about this. So all of the group of people working together in this consensus blockchain are aware of each other's activities without the need for telephone calls or chat systems. They're automatically updated. Some other examples of smart contracts in the drilling domain. Examples might be unsafe situations, the status of the BOPs, as I've already mentioned, calculations such as such as data reductions based upon the change in the rig state, which have implications for the efficiency of how the data is transferred back to the back-end databases. The updating of machine learning algorithms, this coming back from the big data system at the back end, coming to the rig and updating the models, and the fact that the model has been updated and is now running on the edge device, everybody is aware of it. The data science team would know that that new model, that new machine learning algorithm is being run on all of the rigs simultaneously. ROP optimization, which of course can lead to automation in the event that other pieces of information, for example, formation markers, horizon predictions, are linked to a back-end database which contains the formation surfaces and the models linked together with the drilling systems, holds the real promise of automation in the future. KPI calculations, and as I mentioned before, the delivery of these machine learning models. And this is scalable. This is scalable to multiple number of rigs, multiple number of days for the entire number of days in the well construction process. Multiple actors. So these could be, for example, constant actors who are available and watching every single well, the real-time operations center, instead of monitoring a smaller number of wells, through this automated mechanism would be able to extend their activities to the entire fleet of rigs. The data science teams would know that the models that are running on the edge devices are available on all of the rigs. As soon as they're updated, they're notified by the blockchain. Now, some of these actors are role-based. For example, you could call somebody the company man. You could call somebody the mud man. And some of them are variable. For example, the company man might be on shift or he might be on leave. For example, the logging while drilling contractor could be changed in the middle of the well. So the actors could then probably be individuals. So in the future, we see a possibility of each individual person carrying a digital ID going forwards. And that digital ID is embedded within the smart contract of a particular blockchain for a particular well. And this is maintained through the well construction process and managed by the blockchain administrators. But in addition to people, human actors, there could also be equipment actors. And those equipment actors could be the BOP itself, the pumps, the drilling control systems. These can actually be individual nodes on the blockchain, and they can be updating the other people in the blockchain automatically through, for example, the smart alerting mechanism that I mentioned earlier on. So blockchain offers the ability not only to provide these types of alerts, to provide these types of mechanisms for the recording of metadata, the recording of movements of information from one place to the other, but it also offers real promise for asset digitalization. So here we're talking about the fact that these pieces of equipment who might have a digital ID that would be registered on the blockchain as unique identifiers would be part of this whole infrastructure of the blockchain, which would extend not just to the people involved in the well construction process, the people involved in the support of that drilling of the well, like the real-time operations centers, the geologists, the drillers, all of the people who are supporting that operation, but also all of the pieces of equipment, which of course opens up the potential for using it for things like monitoring of maintenance schedules, monitoring of key parameters in terms of equipment possibility of failing, etc., etc. So this asset digitization of the blockchain offers huge potential. These unique, immutable IDs assigned to absolute individual assets, and the people involved with that will create an infrastructure, a network of key information, which is immutable, cannot be changed, but it can be utilized by the entire set of people who are part of the well construction process. It will provide a unified platform, just like it does for cryptocurrency trading today. In the engineering world, it can provide a unified platform for alerting, multi-asset monitoring, to connect all of the IoT devices in the remote sites, not just in the upstream drilling, but also in the downstream production part of the industry and traditional devices. And the digitalization of all of these parameters will provide reporting alerts and many other fourth industrial revolution opportunities, all supported by this underlying technology of blockchain. So we're going to dive a bit deeper into the use of this for drilling uncertainty prediction. There is the drilling uncertainty prediction technical section, which is another technical section of the Society of Petroleum Engineers, which I'm very pleased to say was started in the Kingdom of Saudi Arabia through the initial Drilling Ahead of the Bit initiative. And it has grown to be one of the biggest technical sections in the drilling part of the Society of Petroleum Engineers. It's currently being led by Salam Garbi. I was the previous president of this for some time, and now Salam has taken over. We have another webinar that's coming next month on the 12th of August, where we're going to be looking more focused on how these consensus blockchains can really be used to mitigate drilling uncertainty. We'd like to welcome all of you to participate in that webinar, and please do pass that on to your colleagues as well. Well, I'm a little bit ahead of schedule, so I'm going now to finish the webinar and pass back to the moderator. Thank you everybody for listening. I'm going to go on to the questions, and if we have some people there who've got some particularly technical questions, I'm going to ask my colleague Qing Yang of B2B Matrix to assist me. He is the solutions architect for the blockchain systems that are being developed by B2B Matrix. Thank you very much.
First of all, thank you very much again, Mr. Curtis, for this fruitful presentation. We have received actually multiple questions, so since we're ahead of schedule, hopefully we can address most of them. I will begin with a question that is stating, is the conventional IT infrastructure within an organization suitable for this technology, or the operators are to consider a full revamp of their existing setup?
Thank you for the question. So the blockchain technology operates over TCP/IP circuits. It is a piece of data that moves from one location to another. So it's in that way, it's similar to an email that might pass over a link. It's similar to a spreadsheet that might be moved. It's using this distributed ledger technology, and the replication, the automation movement of this data is a little bit like, some of you might remember Lotus Notes, a product that was superseded really in the email world by the Outlook systems in place today. But Lotus Notes had a very, very powerful capability, which was the replication of information within the database in one location to another. And this is how the blockchain works. It is suitable for transfer over existing networks. It will coincide. It uses particular ports. And those particular ports do need to be enabled, obviously, by the IT department in the way that certain ports are used for other types of information. I just want to mention here, in terms of equipment, equipment is typically connected to a data acquisition system by Modbus, Profibus, OPC tags, a lot of other systems like that. This technology is perfectly suitable for capturing that information and entering it onto the blockchain, and then transmitting it through the existing system. So no change in the infrastructure in the current existing infrastructure is necessary to implement this system. Thank you for the question.
And in the same regard, is there a transition phase between the blockchain technology implementation and the traditional way of data exchange and the centralized ledgers?
Yes, this is a very good question. Thank you. I think it's probably fair to say that blockchain itself is probably not the suitable mechanism for the transfers of large amounts of information. So if we talk about real-time data that's being transferred, that's being sent in, for example, using one of the WITSML structures, ETP structure coming from the rig into the back-end databases, probably blockchain is not a recommended mechanism for the transfer of that type of data. But it can be used to tell the actors that the data has started, that it has stopped, and that it is moving. Now, if you talk about static data files, for example, drilling reports, geological reports, these are much smaller data files. These can be embedded within the blockchain structure itself. Thank you for the question.
And also we have one more question on what are the infrastructure requirements generally and popular suppliers of the blockchain?
Yes, the infrastructure requirements, you do have to have some servers available. Now, here it's important to make the distinction, which I tried to do early in the webinar, that blockchain is the underlying technology. Like any computing mechanism that has powerful replication capabilities, it does require some computing power, but it doesn't require huge armies of computers that are hooked together. So the difference between the public blockchain, which is essentially still used for cryptocurrency for the creation of digital currencies like Bitcoin, does require a lot of computing power. So for the proof of concepts that we have worked on so far, because just a reminder to everybody, this is a new emerging technology in the engineering sector. But those proof of concepts that we have worked on, that I have worked on with Qing Yang, indicate that we can actually run it on a laptop, on a desktop machine, on regular servers, that we don't require huge computing power. But clearly, if the blockchain becomes very large, if it starts to incorporate a lot of information which encompasses many different aspects of the well construction process, then one would have to scale up accordingly. But it uses existing current hardware. Most of the blockchain server backends are Linux based, so the requirement for licensing cost is very much lower than you might expect. And typically the nodes that exist and the remote sites can also be running on Linux as well. So there are implications for cost reductions there. Thank you for the question.
Right. Our next question will be by Mohammed Al-Nahas. How critical is the blockchain technology in enhancing IT governance in corporations and in the public sector as we are taking accelerated strides into becoming a digital economy?
Okay, was that the IT? Did I hear Akram there who said the IT? How is important it's in the IT world?
Correct. How critical is the blockchain technology in enhancing the IT governance?
Well, I think it can be, because I went through the fact that information which is stored on the blockchain is immutable. People can't, because of the way it functions, people can't go back or it's so exceedingly difficult to go back and change all the blocks on a record that it's unlikely to happen. In terms of IT infrastructure, it does have some potential. So, for example, if somebody changes a firewall, for example, an IT person changes the configuration of a firewall to allow somebody in or to stop somebody from accessing a particular source, that change itself, the change of state of the firewall, can also be recorded on the blockchain. So as a ledger to monitor activity of people who are connected, the nodes on the blockchain, it does have considerable potential. In the case of cybersecurity, I believe it does have considerable potential to reduce the risk, particularly in the remote sites. Now, if I may just divert, because it is relevant to the conversation, one of the problems that we have had in the upstream oil and gas industry for a very long time is the problem of interconnectivity of the pieces of equipment on the rig. So even today, there is no such thing as a digital rig. You might have a BOP provided by one manufacturer, a drilling acquisition system by another, some pumps, some other pieces of equipment which need to work together in the same way that an aeroplane is manufactured by lots of different companies that manufacture the pieces, and it flies. If it didn't fly, or if we thought there was a risk it wasn't going to fly, we wouldn't get on the aeroplane. But the drilling rig today is still essentially the same as it was 30, 40 years ago, in the sense that there is no mechanism for the connection of the pieces of equipment. So, for example, the operator doesn't trust the suppliers. The suppliers send data into the system, which is thoroughly checked for viruses and other problems. But the suppliers on the rig don't trust each other either. So they've all got individual networks, and pieces of equipment all come back into control systems. And this is very inefficient and leads almost certainly to non-productive time, and certainly leads to invisible lost time in terms of lack of efficiency or reduced efficiency. So the potential of blockchain to provide a mechanism, a cybersecurity mechanism, that will enable all of these pieces of equipment to be connected together is very, very big. And I predict that in our industry, cybersecurity is going to be one of those sectors, and the IT part, because I noticed that several questions are related to IT here at the moment. I think that if people study this and look at what it can do and start proof of concepts going in their own departments, I think we will see that the potential, because of the inherent security and the records, the immutable records of what is done, like a firewall change, for example, will prove that it is going to be an exceedingly valuable technology going forward. Thank you, Akram, for passing the question.
Sure, not a problem. We have one more question by Wa'il Harbi. What do you envision the next version of the blockchain to be?
Well, I think that if we could all predict, because remember, this is a technology that's largely being driven by people like Qing Yang. So basically, a lot of the software that's available, a lot of the user groups are open source. A lot of the tools that are used to build blockchain servers are open source. A lot of the users, the creation of Bitcoin itself was caused by people who went in to look at, figure out what's going on, how does this work, can I make a living out of it, can I make a profit out of it? And so they generated and developed this new technology on the basis of the fact that there was a profit to be made, or there was an efficiency to be gained. So I think that in terms of what the next generation is, the blockchain itself, and Qing Yang may want to come on here if you could perhaps release his microphone for me, Akram. He might like to come and make a comment here. But the real power of what we're doing are the smart contracts. These are the embedded pieces of code that are embedded within the blockchain that execute events. So what I tried to show in the example was how a drilling alert, which came from a piece of equipment that would normally not be going back or could be running on managed by exception system, a very sophisticated alert that's coming from equipment, can be embedded within the blockchain by using some form of messaging protocol. For example, RabbitMQ or MQTT protocols can transfer these alerts into the system, and then these alerts, when they're received, triggers a smart contract. So the example I showed again, just to remind everybody, was the triggering of a notification to the actors on the system, the drilling engineer, the drilling superintendent, the real-time operations center, and then their capability to acknowledge the fact that they have seen it. But it could do many other things. It could trigger a sequence of other algorithms which produce other events. I'll be as bold to say here that I think that blockchain integrated with modern technology could finally herald the arrival of true rig automation. But we'll wait to be seen. If I could predict that, and other people could predict it, I'm sure they'd be very happy. But I think it's a technology that is a new technology, which is exciting, fascinating. I've hoped to cover some of the basics in the webinar, so maybe people will go and have a closer look and maybe see how it can help them in their particular user groups, in their departments, how it might be able to help them going forwards. Thank you for the question, Akram.
So we have one more question, since you mentioned on the smart contracts, on how do you adapt the blockchain for smart contracts in order to avoid loss or theft due to bugs in the blockchain?
Ah, that is a good one. Now, if you could please release, I'm gonna pass the buck here. I'm going to give that to Qing Yang, because yes, it is one of the issues is if you have a piece of bad code in a smart contract, it may very well duplicate itself elsewhere. Qing, are you online? Would you be able to take that question for me?
Yes, John. I think this is a great question, and it's a hot topic in this industry. So smart contracts will need to be tested intensively. So to avoid any bugs, and it has to be signed and agreed, reviewed by all the blockchain participants. So there are standard procedures to review smart contracts, standard format of the smart contracts to avoid these kind of bugs.
Akram, I think the conclusion is there is a slight weak point there which does need to be identified and does need to be focused on going forwards. Thank you for the question. Thank you, Qing.
Okay.
Right, our next question would be that we know that the mining process is the power intensive and gets worse with the complexity of the blockchain processing. How is that a fallback? How is that fallback being addressed?
So again, I'll come in and ask the specialist Qing to answer that. But earlier I focused on the fact that the public blockchain, which is the type of blockchain where anybody can join and get a copy of the ledger and may need to try and solve the cryptographic puzzle to create digital currency, that does require excessive computing power and does require therefore a lot of electricity. Ching, maybe you can come and talk a bit more about consensus blockchains and why those don't require as much computing power, please.
Yeah, John, that's right. And mining is mostly involved in by this only in public blockchain and cryptocurrencies. So we are using a permission blockchain. Every participant are identified. So and so there's no mining involved. The processing throughput is very high. It's much higher than a public blockchain. So, for example, Bitcoin, to process a block, it takes 10 minutes. But with in permission blockchain, it's much shorter. We can process over 1,000 transactions within a second. And there's no mining. There's no power. It's not power intensive.
So, for example, in a public blockchain, you might have thousands of people participating, correct, Ching?
Yes, thousands of people competing to generate a block to get paid by the.
But in the consortium or private blockchain shown on the right here, if you can still see my screen, everybody, on the consortium blockchain, as I showed in the example in the webinar, we may only have 10 people participating in one particular blockchain who are participating, for example, in the well construction process. Now, that could be, if you were to take all of the people who might be involved in the well construction process, say, for example, in Saudi Aramco, and you had hundreds of rigs and you had perhaps 10 actors in every one, you could come to the position where you might have 2,000 or 3,000, but that would be the maximum number of actors in the entire private consortium, correct, Ching?
Yes, that's correct, John.
And just to remind everybody, these are pre-approved. These basically, the person who creates the smart contract knows who the people are. The general public is not allowed in. The applicants are pre-approved by the IT department. So one assumes that the IT department of the operator who's implementing the smart contract and the blockchain knows who all the people are. Those participants may be people. They may be groups of people like the Real-Time Operations Center that receive one alert, and they may be pieces of equipment as well that participate in that. But essentially, they're private and they're managed internally. Thank you for the question, Akram.
Sure, and I believe this is going to be our last questions, just to be for sake of time. And this is by Sagar Ramchandran. I hope I'm pronouncing the name right. Are there any limitations as to which type of information and data standards that blockchain technology can be implemented on?
Well, first of all, data standards. So the blockchain process doesn't use a public standard. For example, the real-time data might come in using a WITSML standard that people will have heard of in the drilling domain. So the blockchain uses its own communication network for the information. And I mentioned earlier that you can put in, and perhaps Ching, you could give me some idea here of this. What would you say is a practical limitation of the size of a file that can be included in a block that is moved in a blockchain? Can you give the audience some idea of that?
Yes, John. I think generally we should not store a large file or real-time data stream in the blockchain, but we can store metadata of the data itself on the blockchain. So I think the limitation, I don't think it's a limitation. It's the implementation of blockchain that we only store metadata and structured data on the blockchain.
Yes. So, for example, just finally there, it could be if you had a real-time data stream of drilling data, the metadata that might be stored on the blockchain is the fact that there are 10 drilling parameters: weight on bit, standby pressure, etc. And there are 10 parameters, and those parameters, the data started. It's sending at a frequency of 1 hertz, 1 sample per second. It started at 4 o'clock in the morning and it ended at 5 o'clock in the afternoon, for example. So the metadata, which actually is a problem for real-time data, because quite often real-time data is received, but a lot of associated metadata is missing, which makes the calculation of key performance indicators, engineering engineering calculations, for example, stuck pipe algorithms or torque and drag plots, these types of engineering calculations often need metadata that's not available in the real-time data stream. So by having this available to all the actors simultaneously on the blockchain would enable everybody who needs it, that metadata would get it at the right time. Akram, thank you for that last question.
Sure, not a problem. So I would like to again thank you very much for your time, Mr. Curtis, and also, if you don't mind, I would like to thank Ching for his contribution as well. So just would you like to leave us with any final word or advice from your end before we conclude?
Yes, I think, you know, it's quite rare that a new technology comes along which is going to have a major impact, not just on our industry, but on every part of the energy industry and every part of industries worldwide. This is going to have a major impact because of its capabilities. So I suppose the last thing I would say is watch this space, because there are going to be more and more people talking about it. There are going to be more and more people running proof of concept, seeing how it might assist. There are lots of bottlenecks in the movement of data, particularly in our part of the upstream part of the oil and gas industry. There's lots of problems with data silos, with the efficient sharing of information, and I believe that this network of capability is going to have an impact, and I look forward to everybody coming along for the ride.
Hopefully. Well, again, thank you so much for your time. And just a final reminder for everyone attending with us tonight, be sure to follow us on the social media accounts, specifically on Twitter, for the next webinars and all the SPE-KSA events. And with that, we conclude our webinar for tonight. Wish you a safe time and a safe week. And thank you very much.
Thank you.